All right, hello everyone. I do have the top of the hour on my clock, so we are going to get started so that we have enough time to get through everything today. Hope you're all having a good day so far. I'd like to thank you for joining me for this webinar on improving infrastructure resilience against extreme weather. So I am your host, Sam Justice, and I'm a licensed professional engineer in the states of Wisconsin and Kentucky, and I have degrees in both civil and geotechnical engineering. I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer both technical and site support, as well as free project evaluations from our in-house engineering team, like myself. So a little bit of a summary about what we're going to be covering today. I hope you can understand how our products can provide permanent solutions in building roads as well as alongside your roadways. Understand how the GeoCell system can work in challenging soil environments. Learn about different applications where GeoCells can be used in roadway building. Learn how they can help manage stormwater and stabilize slopes in your right-of-ways, and learn how geocells can help prolong your pavement life. So first, a little bit about Presto Geosystems. If you are unfamiliar with us, we worked with the U.S. Army Corps of Engineers to develop the geocell technology in the late 1970s, and we have been innovating in this market ever since. Our products have been used in nearly 200 countries and in every state in the United States. We go beyond simply providing a product to helping provide you a complete stabilization solution. So we do operate in three main product areas. The first with the GeoWeb GeoCell system, which can be used for load support, slope and channel protection, and constructing green retaining walls. And then we also cover porous pavements, of which we have both a vegetated and a stone surface solution, and lightweight reusable construction mats. Today, we are going to be focusing on the GeoWeb system and all of its different types of applications. But if you do have questions about our other products, feel free to reach out to me and I'd be more than happy to discuss those with you. So now let's cover some general information about the GeoWeb GeoCells for those of you who may not be familiar with this type of product. If you have watched some of our other webinars or if you are familiar with GeoCells, hopefully this is a good refresher. So the GeoWeb system is our version of the GeoCell technology, and it consists of two main attributes. The first is the cell or the container size. The cells come in three diameters, small, medium, and large openings, with cell heights of 3, 4, 6, 8, and 12 inches. So these dimensions can depend on your project details and your vehicle loading requirements. We can help you determine which one is going to be the most appropriate for your specific job. There is no one size fits all. It is going to be very much dependent on your conditions, what your loading requirements are, all of that good stuff. And we can help you determine what that is. You don't have to guess. Another thing I want to point out is going to be the ultrasonically welded seam, and that's where all of these connecting points are. It's very important to the function of a geocell. The stronger your seam strength, the better the performance a geocell is going to have. A strong seam allows for heavier infill materials, steeper and taller slopes, and better lifetime performances. The GeoWeb system is produced using a high-quality virgin, high-density polyethylene, HDPE, resin for consistently strong welds at every cell junction, while also maintaining ductile properties within the cell walls, including high stress crack resistance and overall toughness and long-term durability in all environmental conditions. Our geocells do not use any fillers or exotic polymer alloy blends, which can ultimately reduce your weld strength and your environmental stress crack resistance. Those type of things, polymers, that sort of thing, are offered in some of the competing products that are available on the market in the name of increasing cell wall stiffness. But to avoid weld failures and the damaging effects of differential settlement, you need to focus on uniformity in your performance across all elements of a geocell system, much more than you need to focus on a single characteristic alone. I did mention there were two main attributes to a geocell system. The second one is going to be the infill material that you choose. So that's going to be what you put into all of those containers. An important benefit of the GeoWeb system is that even low quality aggregates, sands, and salvaged materials that you get from excavating on site can be used to infill the cells. Using that salvaged material can save significant amounts of money on material and hauling costs, and you don't need that expensive engineered stone if you can just use what you've already excavated on site. You can also potentially eliminate the fines content of your material because the cells themselves provide the confinement and aid in compaction of cohesionless soils, so a sand or a granular material. Without fines, you can significantly improve the drainage of the system and let water flow freely through the system, preventing poor pressure buildup, which could potentially cause global failure across the cross section. So that ability to use sands or other low quality aggregates really sets the GeoWeb system apart from planar geogrids or geotextiles that you might be more familiar with. Those types of products, those planar materials, require high quality aggregates to have a very high friction angle to achieve optimal performance. So you really need that stone to have that lockup material to get the best performance out of a geogrid. With the GeoWeb system, low friction angle materials are just fine. The GeoWeb panels can still achieve their full potential even when using poor quality materials. So huge potential for cost savings there. Another thing just to sort of point out, the GeoWeb system and all of our accessories are 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements in the Build America, Buy America, BABA, or the Infrastructure Investments and Jobs Act, IIJA acts. So if you are looking for some federal dollars, or if you are in a regulation where it needs to be a made in the USA product, all of our products meet those standards, so they are good to go. Okay, so the GeoWeb panels are obviously the big component of how a geocell system works, but you do need some supporting components, some extra pieces to have a complete geocell system. And so to have that, you need a uniform performance across your interconnected system, which helps you protect against that differential settlement that we talked about, all of that good stuff. So let's look at a couple of these components that are going to be some integral pieces of how this system can work. So if we think back a couple slides, I mentioned how the GeoWeb system can come in discrete sections. Mostly they are around 250 square feet, give or take. Your project is probably going to be bigger than that. So you're going to need more than one panel and you're going to have to connect them together. So the AtraKey is that first component of a completely integrated system, connecting each individual panel of the GeoWeb into a single system that covers your entire project site. It allows for faster installation of the panels and is going to last the lifetime of the project, ensuring that your road, slope, channel, what have you, is fully protected and that the GeoWeb system is not going to fail under anticipated loads. And so the specific engineering values of the AtraKey will ensure that the system will hold up to loading over time without the corrosion that you would see with metal staples or failure from underperforming cable tie systems. And our spec sheets do call out these specific engineering values for this patented connector. So it's definitely something to look out for if you are getting hit with a substitution or an or equals from your contractor. Make sure you look and make sure that all of those specifications are being met. Similar to the AtraKey is the AtraWall-Key. This is made specifically for when the GeoWeb system makes retaining walls. You can see in this picture here. And so this goes in that front face that would be exposed. And so it helps cover any holes or any gaps so that you don't lose material, but still holds all of the panels together with that strong, long-lasting HDPE resin so that you have that completely integrated system. Also is colored so that you can match the color of your retaining walls. And so it is formulated to withstand weathering, ultraviolet radiation, exposure to the elements, all of that good stuff. It's not going to corrode, it's not going to photodegrade, all of that things. It is a long-lasting product. So something to keep in Now, if we are looking at slopes, or if you're in a channel situation, anywhere basically that you're not on a flat slope, you are potentially going to need to anchor the GeoWeb panels in place so that they don't slide. You can do that with one of two ways. If it's a relatively shallow slope, you can use stake anchorage to hold it in place. We do offer two options for stakes, one being with metal rebar, or you can do fully HDPE stakes. That's what you see in the picture on the left there. Those are called our Atras Speed stakes. So if you are in potentially a corrosive environment, maybe you're along a coastline with seawater and you don't want to have to deal with corrosion of metal stakes, these fully HDPE stakes are a great option. And so the stakes hold the GeoWeb panels in place so that they aren't going to slide down to the toe, make sure that everything is going to last the lifetime of the project. If you are on a steeper slope, or if maybe you don't want to puncture use stakes to puncture anything, maybe you have a geomembrane liner underneath here, you don't want to puncture that with a stake, that sort of defeats the purpose of a liner, you can use a tendon anchorage system. So this is something that sort of floats the GeoWeb panel over your slope face and anchors it at the top of the slope. So the tendons are run through the panels, as you can see here on the photo, and we have our Atra tendon clip, which is a specifically designed load transfer device to connect the tendons to the GeoWeb panels and run those all the way up to the crest anchorage system, which is holding them in place. So it is definitely a great option if you are in those steep slopes, like I said, or if you're not interested in puncturing or putting stakes into your slope face for whatever reason. We can help you determine which anchorage system is necessary and what it's going to look like, how many stakes, how many tendons, what your required strengths are, all that sort of thing. Again, it is no one right size fits all. It is very project dependent, but that is why myself and the rest of the engineering team are here to help you get you those answers. And we just like to show off what a specification sheet should look like for a GeoCell. Like I said, there are a number of competing products out on the market. I'm pretty sure everybody has seen some cheap Chinese knockoffs come in for pretty much any type of product. GeoCells are not different in that regard, but the GeoWeb system is the industry standard for what a GeoCell should look like, and our specification sheet holds that standard. And so we really urge you to hold your spec, make sure that the material that you're getting is going to meet or exceed these standards so that you're building with materials that you trust, so that you know that these are going to last in your environmental conditions. They're going to be long lasting for however long your project is. These types of materials, if properly made and installed, can last decades. So it's really important that you know that what you're going to do is appropriate for your site, and that you're not just putting in, you know, a cheap bit of plastic. You want the thing that is actually going to do the work that you need it to do. So just keep that in mind. We're always happy to answer questions about this, help you hold your spec if you are getting pushback from contractors or regulators or anybody. This is something that we deal with frequently. I'm sure everybody gets that sort of thing in their industry, so it is definitely something we are familiar with and are happy to help with. All right, so background in that case done. So let's look at the GeoWeb system, and we're going to start with it for load support applications. And for us, load support is supporting vehicles. So we want to be able to drive cars, trucks, dump trucks, construction equipment, cranes, anything like that over the GeoWeb system, especially in very soft soil environments. And so for us, roadways consist of anything from driveway all the way up to highway applications. You can have unpaved roads where you have stone surface. You can build up road shoulders. You can do base stabilization underneath paved roads. So if you want to have an asphalt or concrete or a paver block road, you can do that. Put the GeoWeb system underneath it for support. And you can also have some stormwater control when this is done with GeoWeb underneath or as your road surface. You can have roadside ditches. You can have drainage channels, culvert outflows, or just allow for water movement underneath your paved roads. So lots of different things that you can handle with the GeoWeb system. So the purpose of cellular confinement, of GeoCells, is pretty simple overall. you want to stabilize the movement of unstable soils, both horizontally and vertically. So the weaker your subgrade conditions, the more practical it becomes to insert the GeoWeb system into your cross section. So it's an engineered system integrating potentially multiple types of geosynthetics with the best method for confinement and subgrade stress reduction in the industry. And so we're going to talk about, the GeoWeb system specifically for roadway infrastructures, but keep in mind that it does have other applications that we're going to get to at the end as well. So the GeoWeb system works like this. When a vertical load is applied, such as a vehicle tire, the active earth pressures in the loaded cell push back against the passive earth pressures in the adjacent cells to form that stable system. Being confined, the soil responds passively. The infill is limited in its movements, represented by those yellow arrows, and then the cells adjacent to the loaded cell, where the vehicle tire is, provide the passive resistance, and that's shown in the red arrows. And then the load is dispersed over a greater area in the lower layers as each cell helps supports the one around it. So the GeoWeb cells also transfer hoop stress, which is really important in keeping the system intact and creating what we call the mattress effect. You're going to hear that term a lot, so I hope we can understand it. So the strength of the seams around each cell, the material properties of each individual strip, and the connection method between the panels, so that's that ATRA key that we talked about, are all important factors in determining how a geocell system can improve the load-bearing capacity of a site. Strong seams, proper resin properties, and integrated connectors are critical to a well-performing system. And the GeoWeb system and all of its accessories are specifically designed to work together to be an effective, permanent solution for roads in soft soil locations. So in a load support scenario, vertical deformation can only occur with either compression or compaction of the soils or through lateral movement of those soil particles, so if they get pushed away from the tires. By spreading out the load in a classic granular fill approach, you can reduce the compaction of near surface soils, but only with cellular confinement, only with the GeoWeb system, can you be assured that there's no lateral shifting of the material that leads to rutting. And so that's the mattress effect again, which reduces the stress reaching your subgrade. And here you can see how that stress is reduced. And so we're looking at an unreinforced section on the left and then the GeoWeb reinforced section on the right. So you can see how in this stress bulb underneath your tire, there's actually a complete elimination of the highest stresses, the red and the orange level of stress, underneath the GeoWeb panels. So the stresses are reduced and then they're also spread out significantly wider. So you're really widening out that stress bulb for that mattress effect scenario. And that mattress effect reduces that stress reaching your subgrade and leads to that significant decrease in overall deflection, differential settlement, and rutting. And so by eliminating particle movement, so that moving from side to side, getting pushed around by tires, the GeoWeb system can stabilize the surface of the roadway if it's an unpaved surface, eliminating or reducing the need for constant maintenance. All right, so here you can see how that geocell, how the cells work together. Underneath, in this case, this was an 80,000 pound loaded dump truck. So AASHTO H20 standards, if you are in the US, if you are familiar with AASHTO loading parameters. And so this is only obviously a partially filled GeoWeb panel. And so you can see how the cells push back against one another to support the load, and that only a single adjacent cell needs to be filled. You don't have to have the entire panel filled with material before you can start driving on it. So it's a great benefit of using the GeoWeb system that you don't have to do that. You don't have to completely fill in the panels before you can use it. So you can actually sort of build out your own road as you're going, keep filling in the cells and the panels in front of you as you're going, and immediately start driving on it. So it's a great way to reduce your construction time, reduce materials. You don't need to build additional temporary access roads, anything like that. So it's a really great approach. So the GeoWeb system is often compared to GeoGrids, so it's the 2D planar system, and they do start with a similar concept. However, due to the 3D nature of the GeoWeb system, the fact that it starts with a defined depth, plus the integrated infill geosynthetic system, it acts as a composite layer where the lateral earth pressures are mobilized and transferred across that three-dimensional network of interconnected cells. Again, mattress effect. And so because of this phenomenon, lower quality fill materials, such as sand or excavated materials of unknown gradation, can be used in the infill of the cell. So you don't need to bring expensive stone. And that's one of the big things with geogrids, is that you do need specific engineered stone on site to get the full performance of a geogrid. So the GeoWeb system can often result in a thinner cross section as well compared to a geogrid. A 6-inch deep GeoWeb panel is equivalent to a 12-inch deep geogrid section, which could potentially even need 2 layers of grid within that 12 inches of aggregate. So definitely you can see there's some real potential savings there as well. And again, you can eliminate the fines content of your infill material. You can use a clean washed stone, and then so you're allowing for water to flow through the system, but the GeoWeb panels allow for it to still be locked up and confined, so you're not getting that particle movement. And basically, one last thing is the geogrids don't confine the material. It is just a plain, it's sort of like a piece of paper laying down. So it's obviously not stopping that stone from getting pushed side to side and being rutted by the vehicles as they drive across. The GeoWeb panels do prevent that lateral movement. They do stop that side to side rutting. So you are going to have less overall maintenance with a GeoWeb system because you're not going to have to go back and fix those ruts that way that you would with a GeoGrid system. So a number of benefits. More than happy to get into those more if you do have questions. But if you are familiar with how GeoGrids can help roadways, GeoCells and the GeoWeb system specifically are a similar concept, but at least in our mind, better. All right. Moving on. So continuing with the theme of unpaved gravel stone surfaces, a washed or a clear stone can be used in the GeoWeb system. I mentioned that a couple of times, but it allows you to build stable and permeable low impact development access roads. So site access roads, either temporary or permanent, are a really common application of the GeoWeb system. So this is a great way to allow for these low impact development pathways or roads because they're not impeding water flow and infiltration into the groundwater system. You're not getting surface runoff the way that you would with a paved surface. So this is a great way to go into the more environmentally sensitive areas. Or if you are in conditions where you've met your hard surface goals, if you're maybe building parking lots around a building and you've put in your parking lot and it's all paved asphalt, but then you need more parking spaces, but you're out of hard surface pavement, put in a permeable system with the GeoWeb system. And it's a great way to support those vehicle loads, still allow for water infiltration. And the GeoWeb panels can help bridge soft, wet ground. You can see the inset photo here. It is more than wet. It is standing water at the surface. And so this is a great way to be able to build access roads through these areas that otherwise would not be able to support very heavy vehicle loads. You could imagine maintenance trucks or emergency vehicles, anything like that, getting really bogged down in these completely saturated environments. The GeoWeb system allows you to build roadways through here. You're still allowing all that water to move through. So if you're in those sensitive locations, you're not impeding that water flow, but now you can support heavier vehicle loads. You're not going to get bogged down. You're not going to rut. You're not going to tear up the ground, which could potentially impact your environmentally sensitive conditions, that sort of thing. So this is a really great way to get to potentially remote or hard to reach areas. You can see that here. This was actually post-hurricane repair. It was down in Florida. This was for Duke Energy. They had needed to repair and install over 100 transmission towers that had been knocked down by Hurricane Michael. So you can see the photo there. They're getting ready to put a new tower in, but you can see how soft this ground is. It is completely saturated. There's standing water, and look how deep footprints are. That's, you know, if that's what a footprint is doing, imagine trying to get construction vehicles down here or maintenance vehicles. They're going to just completely tear up the ground. They're going to get caught. It's going to be a mess. So by putting in the GeoWeb system, they were able to get out into these really remote areas, use the material that they excavated on site. So this really unknown gradation material, they weren't sure what the fines content of it was going to be. They didn't know really anything about it, but they didn't want to have to truck in material because that's a significant hauling cost to bring all this material out here for the entire line of transmission towers. So they excavated out the material, put the GeoWeb system down, and then reused all of that excavated material, just putting it back into the GeoWeb panels. And so this is a great way to save time, save money, save all that cost that you need, and get things just done faster because you can take it out or to excavate the material, put the GeoWeb panels in, and then just throw that material back in the ground. And so here you can see what it's starting to look like further off into the distance, our unfilled GeoWeb panels, but we're starting to fill it in, drive on it, get all those towers all the way up. And so now this is going to be a long-lasting solution. Hopefully they don't get any more significant hurricane damage, but Florida does get lots of hurricanes, so we can't guarantee that it won't happen again. But now the GeoWeb system is there, and they are able to use that to maintain, hopefully minimal replacements, that sort of thing. So this is a great way to have this sort of permanent access road in remote and hard to reach conditions. So another thing that the GeoWeb system can do is that it can do embankment stabilization. And so this is moving away from using it as your roadway surface and using it on the sides of your road, but it's a great way to either limit the amount of erosion coming off your embankments, maybe you need to steepen them up because you're running out of space, that sort of thing. So we're going to talk about how the GeoWeb system can be used on slopes. So like I said, can be used on slopes. Again, you have a number of different materials that you can put in there. You can do soft armor protection, which is basically filling it in with topsoil and allowing for vegetation growth, or hard armor protection. You can do it permeable by filling in with stone, or impermeable by filling it in with concrete. So a number of different options. We will say that the filling in with topsoil and vegetation is by far the most common and most requested application. This is sort of the aesthetic look. You know, then you have a nice green slope. It doesn't look like it's built up and protected. You don't see the plastic material. So you can imagine why topsoil is the requested option. Sometimes it's not the right option though. Maybe you're not in a climate that can grow vegetation, so put in stone. Maybe you know you're going to have really high velocity flows over the top of it, put in concrete. Lots of different options. We can work with you to get you the right option. All right, component diagram, pretty simple. So basically you're going to put it on the slope. You potentially need to put down a geomembrane liner if that is something that your site needs. And then you put the GeoWeb panel directly on top of that. You do your anchorage system. We talked about that back in the beginning. You can either do stakes or you can do tendons with crest anchorage. Crest anchorage usually is going to be a buried dead man pipe. It could be earth anchors or rock anchors. You can also tie off to buildings or structures that might be at the edge of your slope. If you are putting in a slope right next to a building, you might not have room to to dig out an anchor trench because you've got that building there. But maybe that building is strong enough that you can bolt in a eye bolt and then tie off the tendon to that. So number of different options for what your crest anchorage is, but it's up there if you are doing a tendon system. And then you put in your infill material. Again, you can do topsoil, stone, or concrete, and then you can allow that to vegetate or not, depending on what you're looking at. And that's pretty much it. You know, again, projects dependent. We are here to help you determine what is going to be the most appropriate for your job. But this is basic, basic component diagram of what we're looking at here. So the GeoWeb system, when on a slope, is intended to help break up large mass of soil. So it basically separates and confines all of the soil into the smaller segments, into each one of those containers. And that helps resist mobilization of your entire slope face that might cause sloughing or mass movement due to water flow, wind erosion, what have you, whatever your failure method is. And so it is important to reiterate that it is a surficial erosion protection. This type of GeoWeb system is not intended to fix global stability issues. If you know you've got a deep-seated failure, if you've got circular failures, if you have very large mass movement of your entire slope, this GeoWeb system is not going to fix that. It is intended to help prevent surface erosion due to water flow, due to wind flow, anything like that. So it is surface only, so your slope does need to be stable. But it does help prevent the erosion. It doesn't allow for the formation of rills and gullies because the material is confined within the cells. It's not going to get washed out. It's not going to get picked up and moved by the wind, and you can allow for vegetation growth if that's what you're looking for. So this was a vegetated slope on an unstable soil slope. It was up in northern Canada at an active gold mine, which I think is kind of cool. And so you can see there are some variable slope lengths. The face angle was changing a little bit, and it was a pretty confined slope. They couldn't necessarily change the slope angle because they're going to put a roadway up where that excavator is driving, and you can see they've got vegetation and work happening at the toe of the slope, so they were pretty much stuck with what they had. But it is what it is. We were able to go in and help protect that surface, that slope surface from erosion, able to put in local soil and then allow that to vegetate. You can see the green grass in the lower right-hand photo there. Looks really nice. You don't see the plastic material once that vegetation has started growing, so it looks really natural. Looks just like a regular slope. Most people wouldn't even know that it's protected. So that's kind of cool. If we are talking about roadway embankments, you are typically going to have other infrastructure around and maybe even through the GeoWeb system when it's on a slope. Things like guardrails, fence posts, if you're going up against bridge abutments or bridge approaches, anything like that, you can either work around if it's already existing, or you can install with the GeoWeb system. So if you do have guardrail posts, that sort of thing, you can put those right through the GeoWeb panels at the edge of the crest if you need to. But it's a great way to help protect that slope. You're not going to have erosion that could potentially undermine your roadway, that sort of thing. And it's really good if you are in these limited space constraints where you don't have the ability to flatten out your slope for whatever reason. Again, alongside roadways is really common. This is probably one of our most common applications. So in this case, it was in Ohio, and this slope was washing out very frequently. They didn't have large vegetation. They'd removed all of the trees and things close to the roadways for line of sight. But by removing the trees, they'd made it a erodible surface. And so they put the GeoWeb panel down over the surface of the slope, filled it in with soil. In this case, they hydroseeded that soil just to try and get that vegetation to grow a little quicker. And so that it would be a nice green slope, you'd have your good line of sight, but they wouldn't have to keep coming in and cleaning out the road after every rain event washed soil onto the slope. So this is a good preventative maintenance solution in these type of things where the slope itself maybe isn't failing, but if you've got to come out and clean the roadway after it rains, that's just a pain and not a great use of anybody's time. So this is a great way to prevent that from happening in the first place. This was another roadway embankment. This was over in Maryland. So they were getting sheet flow off of the roadway, and it was eroding the slope next to the highway, and they were concerned that it was going to potentially start undermining the road. You can see the little photo had some pretty deep rills and gullies. They were getting up to about 4 feet deep those as they were forming. That's still, in this particular case, considered surface erosion because it was happening directly because of the sheet flow runoff. There wasn't piping or underground seepage issues that were causing that, anything like that. It was directly due to that sheet flow. So this was something the GeoWeb system could help with. So by putting the GeoWeb panels in those areas where they were seeing high flow, you fill them back in with soil, you allow for that vegetation to grow back in, and now even with the sheet flow going across the top, you don't have the rills and gullies forming. You don't have to worry about undermining of your road. It's a great, again, preventative maintenance solution so that this roadway is going to last as long as you need it to. You can also help with roadway widening. So if you are running out of space, but you want to expand your roadway, but you can't move your slopes back because you've got houses there, you can steepen up your slopes as long as they are globally stable, but you can steepen up those slopes and then cover them with the GeoWeb system so that they are vegetated, they are not going to wash out due to rain flow, anything like that, and get a little more space for roads, sidewalks, whatever you need. So it's a great way to get a little more space that you otherwise might not be able to if you didn't have this type of surface protection. Okay, let's talk again, some extreme weather. This was another hurricane related event. So this was hurricane erosion mitigation for a riverbank. This was down in South America in the Zaramia River between Peru and Ecuador. So the river itself was full of mangroves, which is good for erosion protection, but the currents when hurricanes came through were such that it would really pick up the settlement and the soil, really eroding around those mangroves because they couldn't handle those high water flows. So because of this, there was some pretty extreme erosion happening. There were some bridges and roadways that were going to become damaged very soon. And experts were predicting more severe storms coming off of the Pacific in coming years due to changes in climate. And so they needed to have some sort of protection against further erosion at this site. So during a brief dry spell in the area, the riverbanks here were all cleared and regraded to allow for the installation of the GeoWeb system. And so this system also provides excellent resistance to that sheet flow from rills and gullies. So coming off of your paved surface, but also coming through the river due to water flow and extreme water flow during hurricane events. So in many cases for this particular project, protection of the slope surface allowed for the construction of steeper embankments with less horizontal footprint, conserving land space. And so the contractors here were able to install about 2.4 million square feet, about 230,000 square meters, if my conversions are right, of the GeoWeb system along compromised riverbank slopes. And so the installation rate here is typically around 1,300 square feet an hour, for a crew of 4, including your operator of an excavator. And so at Zaramia, the contractor was able to further optimize installation by pre-staging sections and assembling the system at the crest before expanding the panels down the slope. So there are ways to also speed up that installation rate if you are in a bit of a time crunch. So the GeoWeb slope shoreline protection system here was filled with concrete because they were very concerned about those future storm events with high water flows. And so if you do have concrete infill, it provides a really economical hard armor protection of your slopes or channels when exposed to high velocities. And in this case, we are talking of velocities of over 36 feet per second. It's around 11 meters per second with really high shear stresses around 21 PSF. So those are going to outperform the capabilities of riprap, gabion baskets, articulated concrete blocks, that sort of thing. So this is a really great option for those hard armor strategies when you know that you're going to have extreme water flow. And so the quality, surface finish, and thickness of your concrete are all things that can be selected during the construction process of the GeoWeb system. And it does comprise of flexible, poured in place sections that are going to be more economical than things like ACBs and don't require specialized equipment to install. So the GeoWeb panels themselves are the formwork for the concrete, so you don't need to build additional forms on your slope. They also ensure that you have a consistent concrete thickness throughout the entire system, and you can install drainage so that you relieve pore pressure so you don't have potential for global failure due to that. So you can see as it's going through here, in this case, the project took about 4 months to install, including excavation work. And now the GeoWeb panels become a flexible concrete slab that conform to subgrade movements, prevents uncontrolled cracking, and reduces the potential for piping and undermining of the system. So this work can also be integrated into existing infrastructure in the area. So the GEOWEB protection was placed up against bridge abutments and formed around culverts and drainage areas. So you don't need to redesign what's already in place. You can work with the roads and the bridges and your landscape to create a solution. And with concrete, it is a very permanent solution, even for the most extreme weather events in this region. And this is just what it looks like after they reflooded the river a couple months down the line. And so you can see that this is performing really well. It's performing above expectations. And now it is providing some much needed protection for the Zarumia River and all of the communities that depend on it. And this is a great permanent solution for a potentially sensitive area. All right, another option for the GEOWEB system, you can build it as retaining walls. So I mentioned the what we just covered with slope protection and shoreline protection did not cover global stability issues. It only covered superficial erosion concerns. If you do have global stability concerns, or if you need an incredibly steep embankment face, think 65, 70, 80 degrees, you are going to need to build it up as a retaining wall rather than surface protection. So the GEOWEB panels can be stacked vertically on top of one another to create retaining walls, and you can include geosynthetic tiebacks for reinforcement to help protect against that internal global stability failure. If you know you've got a big circular failure, you put those tiebacks in to help mitigate that. It is going to be similar to an MSE block wall, if you are familiar with the construction of that. But these walls with the GEOWEB system can be filled with topsoil to create living green walls and can be built to support vehicle and building loads. So there are two options for building these types of retaining walls with the GEOWEB system. You can use gravity style walls, where it is all held in place just by the physical weight of the system. This is going to be for small walls, very short walls. That's just because gravity style walls are much more, have much more potential for sliding failures or that sort of failure if they don't have reinforcements. That's why it needs to be a really small wall. If you're going tall, there's pretty much no limit on the height. We've built 50-foot high tall walls before, but you are going to need geosynthetic reinforcement. This can be things like geogrid tiebacks. It could be earth or rock anchors if you're against a rock face, that sort of thing. So those help hold that wall in place, allow it to be taller, allow it to fix that global stability concern that you might have, that sort of thing. We aren't getting into the design of retaining walls today because that is its whole beast of itself. We do have a webinar coming up about designing retaining walls with the GEOWEB system. So I urge you to look for that in just a couple of weeks, I believe. So we're not getting into it anymore today, but we do have a lot of resources about that I urge you to reach out to us about if you do have questions. So GEOWEB walls do work really well if you are dealing with poor soils with significant settlement concerns or in seismically active areas. Things like masonry block walls aren't great when you know you're going to have a lot of differential settlement. They crack, they break, they fall apart. They're not going to perform the way that they need to. GEOWEB walls are really flexible. They handle that differential settlement really well, and they can withstand seismic activity. So this particular GEOWEB wall saw a major earthquake event in Japan, and it resulted in sliding of the whole area. And you can see how that concrete flume down the center of it just snapped, as one would expect concrete to do during a earthquake event. But the GEOWEB wall itself is totally fine. It's still performing the way that it's supposed to. It's still protecting the slope above and below. So it is a great solution for these types of areas where you have really soft soils. You know that you're going to get that settlement to occur. Earthquakes are going to happen, that sort of thing. It also does really well against rock faces. So this was an Ohio DOT project where a 20-foot high wall was constructed to keep a rock face from eroding further, and it was dumping rock onto this road. Obviously, a huge safety concern to be dropping boulders onto a highway. So the GEWEB system is a fascia that helps protect that road without taking up a lot of horizontal space. And so it is a great option if you know that you have these unstable rock walls or really steep soil slopes in those seismically prone areas. And so the GEWEB wall can support and maintain a smooth wall face during those times. And after a good ground shake, the GEWEB wall is still going to be in place, and it's going to help prevent those rock falls or landslides from compromising your roadway. So it's really great if you are in these potentially concerning areas. Not that we're saying there are earthquakes in Ohio, but in this case, they had a compromised rock face anyway that they were concerned about. You can also do flood control with the GEWEB system because it can handle water flow and being submerged. So by placing the panels along a shoreline, or in this case, a levee, they were able to help protect against erosion due to that water movement and wave action. So like I said, this project was a stormwater diversion channel that helped move hurricane waters in Texas. And so during the hopefully infrequent hurricanes, the channel would flood, and it had been causing some pretty severe erosion every time that water would come through, especially because it was fast moving water. The water level was rising and falling. It was really variable, obviously. And then it was being both saturated and completely dried out. So it was really messing with the soil that was there. And so the GEWEB system was a great way to try and fix that. So like I said, it works great along those channels, and you can place it below and above the water line. So it can handle that variable water flow as it's going through. You can do either stone or soil as your infill. Know that if it's soil and vegetation, that vegetation might drown if it's submerged for a really long time. Most grasses don't like being underwater, but the GEWEB panels are still going to hold everything in place. You're not going to have erosion or failure of the wall. You might just have some dead grass that you need to regrow. If you don't want to deal with that, put in stone or even concrete if you want, so that you don't have to worry about vegetation. But again, everything is still confined. It's still going to be held in place. You're going to allow that water movement to go through without eroding or damaging your channel or your side slopes. And this is what that looks like, facing the opposite direction this time. But you can see it's really nice because it just went up on one side of the channel. They were able to keep it really natural with large trees and everything on the other side. But now it wasn't or isn't going to cause or allow for undermining of the slope. All of the infrastructure that is up above the slope on the far right is going to stay there. Everything is good to go. And now as those water levels change, the water flows change, all of that stuff, you know that you're going to have a good protected system. This is just sort of a fun project. It is not something most of us have to deal with, probably even less than earthquakes, but this is for avalanche protection. So this was a small town in northern Iceland that wanted a permanent avalanche protection wall. And they didn't want it to look too unnatural. Like, it's going to look a little unnatural because they're building a giant wall, but they wanted it to vegetate, so it would at least be a green slope. It would look a little nicer, that sort of thing. And so this was a wall that was actually built from the ground up, completely freestanding. So it's all GEWEB panels supporting it rather than integrating it into an existing slope or wall. And so this is what it looks like. This was immediately after installation, so it is going to get greener than this. It's going to look a little more natural, but again, you know, it is a giant wall right in front of this town. But it was built so that it could be in the path of the most anticipated avalanche. So it was curved and it moved with the landscape, and it protected the majority of this small town. And so the internal strength of the GEWEB wall is such that it can withstand that first huge impact of snow, that big sort of boom impact as the avalanche comes down. And then the structure was also built high enough that it could allow for significant buildup of snow during the avalanche event. And then in this case, they also built access roads up and around to the top of the wall to make sure that these structures stayed clear of obstacles and could be cleaned up after snowfall. And this is sort of what it looks like, again, as vegetation is starting to get established on the wall and on the slopes leading up to it. Eventually, all of that black plastic is hidden from view, and it is just going to look like a slightly unnatural wall protecting this town from an avalanche. But now that's kind of a cool little unique solution to an extreme weather challenge. It is, not something most of us have to be concerned about, but everybody's got their thing that is the concern in your area. Is it an avalanche? Is it an earthquake? Is it a hurricane? What's going to be good in Midwestern United States is not going to be what's necessary in Japan, which is not going to be what's necessary in South America. Everywhere's got its own challenges, and the GeoWeb system is flexible enough to handle all of that. So this is another one. This is for a landslide repair, and this was done in Hawaii. This was leading up to Wheeler Army Air Force Base. And so they'd experienced a series of landslides due to severe rainstorms. This was not necessarily a hurricane, but Hawaii does get inundated with water. And so it had basically washed out a big slope and had undermined, and in this case, broken the roadway leading up to this Air Force Base. This was a 40-day rainstorm is how it's been historically described. It happened in winter of 2006. And so in this case, 6 separate debris avalanches had developed along the roadway. And so it had left basically vertical scarps and some really deep gullies draining down into the main ravine below where the road had been built. And so the site had indicated that it was primarily, I'm going to pronounce this wrong, Pahoehoe lava flows. So although they were weathered, they do have pretty high shear strength. So it's good material, but a 40-day rainstorm is going to just do damage no matter where you are. So in this case, they had done a preliminary design for repair. It had included cast in place concrete walls, micro piles. They thought about doing a shotcrete wall. There was going to be drilled shafts with H-beams. It was going to be everything, but everything is expensive. And so they were looking for a value engineered solution that was going to work a little bit better in the climate of Hawaii, which is very humid, but also it's very important to protect the natural environment in these sort of sensitive locations. So they were looking for something a little less impactful than throwing concrete walls and micro piles and H-beams and all of that out there. So that's where the GeoWeb system came in as a value engineered solution. So they did a bunch of excavation, and so they were able to determine based on the seismic parameters, the anticipated live loads. Remember, this was for an Army base, so there were going to be some pretty heavy vehicle loads that were going to be coming onto this site. So this wasn't just, your cars and pickups. This was going to be, a pretty heavy trafficked road. So they knew that they were going to need a lot of reinforcement for all of that to make sure that that road stayed in place. So they did full excavation underneath where the roadway would be and where the wall would be. So you can see them starting to put everything down. They did lots of good compaction. They did geogrid tiebacks at this site, all the way back to where the roadway was going to be built for that extra support for that heavy trafficked road. And then the GeoWeb panels going out in front of that. You can see them starting to get built up here, looking pretty good, going down into the natural ravine of the slope that was already there that had then gotten significantly worse during that storm event. And so in this case, the GeoWeb solution was able to save about $1.5 million for the client. So it was about a 50% savings from those initial solutions, plus time savings due to smaller excavation requirements, minimal construction equipment, all that good stuff. So it was a really great sort of solution for a sort of challenging climate, challenging area to reach, knowing that they had very specific requirements that they needed to meet. Okay, I'm going to start going a little faster because I'm running out of time. I apologize. So it's our last topic, and we are going to be doing how it can GeoWeb system can handle stormwater control. And so that is by putting it in stormwater diversion channels. So we have done some testing at Colorado State University for the GeoWeb system for topsoil, stone, and concrete infill. So you can put the GeoWeb panels on your channel. You can do it on the bottom, on the side slopes, just the side slopes, embankments, all that good stuff. A lot of flexibility there. But it is intended to be a more economical solution than using large riprap stone or heavy gabion baskets. And so you can see this is with topsoil infill. The GeoWeb system can handle up to 30 feet per second flow over the top and still allow for it to be vegetated. So that's a really great solution if you are looking for that type of, solution, especially if you compare it to the allowable 4 feet per second, if it's just unreinforced soil, a natural soil slope on its own. So that's a massive improvement, 4 feet per second up to 30 feet per second. And so here you can see the GeoWeb system going in on a stormwater channel. This was had an area down in Florida that had some significant bank erosion due to, again, hurricanes. We see a lot of hurricane repair projects. And so you can see there's already infrastructure pretty much on all sides. So it needed to stay within its banks. They didn't want to have erosion potentially undermining anything. So they were able to put the GeoWeb system in. They did it both above and below where that water line is going to be. They did stone below the water because this was a permanently filled channel, so it always had water in it. So they did stone where there was always going to be water, and then they did vegetation above that so it would blend in nicely, and it does. So the GeoWeb protection is on the right-hand side of the photo. You can see a little bit of the stone layer right at the water line, and then it's protected above that and nicely vegetated, grown in. You can now walk along here. It is safe to walk on. You don't have to worry about erosion. But if this channel were to increase its flow or even flood, these channel side slopes are now nice and protected. You can also do concrete or aggregate as your infill material, depending on what you are looking for or what type of environment you're in. If you are in an arid or a desert environment that's not going to grow vegetation, don't bother, put stone in or sand. So you have those types of options as well. And again, we have done testing for allowable flow rates there as well. So we have all of that information available for you to review or to talk about if that is what you are concerned with. But you can definitely do these types of options as well. You can do stacked channels, so you can build retaining walls to make a deep channel that has a relatively low horizontal footprint. You don't have, laid out side slopes. You've got nice steep retaining walls on either side. And again, you can fill in with grass or stone or concrete, so you can have sort of a variable look, allow for vegetation if you know that you're going to be above water, or stone or concrete if you're going to be below water. You can also allow drainage pipes to come in. The top inset photo, you can see a drainage pipe being put right through the GeoWeb walls. That's really easy to do. You can also put the GeoWeb around culverts and do culvert outfall protection. This is a great way to just protect these potentially turbulent areas before the water can get into the channel and flow nicely. Turbulent areas obviously have a lot of concern for erosion. So put the GeoWeb in there. You can mix it with, in this case, they mixed it with large riprap stone. You don't need to do that, but it can be a great sort of multi-use thing depending on what your local regulations say you have to do, what your needs are, that sort of thing. Again, the flexibility and the mix and match aspect of the GeoWeb system is great when you know that you're in these type of conditions. And you can go over culverts as well. You can build retaining walls around new or existing culvert pipes so that you can help protect the area around that culvert pipe. You can even build up a retaining wall so that you can drive over the pipes, and that way you are reducing the stress reaching your pipe. So remember, the GeoWeb system, when it's in a load support application, reduces the stress from vehicles on your subgrade, you can build that up with as a retaining wall with the GeoWeb system and build it as your roadway so that you're not getting vehicle stresses, which could damage or deform your culvert pipes because they're protected by the GeoWeb panels. And you can also, in this case, you see they put sonotubes in. This is great if you have utilities or if you know that you're going to need to get into the soil behind the culvert for whatever reason. Put those sonotubes in, and then you have your access right there, right through the GeoWeb panels. So really kind of a cool project, but it's a great way to meet these type of needs if you know that you're limited to this location. You've got to cross this stream and it has to have a culvert pipe. This is a great way to protect that. All right, summary. I technically made it. So every project is different, but with the GeoWeb system, we can have the right solution for you. You can build your roadways and they're gonna last a lot longer. You can have embankment protection, channel protection. You can build them up as superficial erosion or get some global stability in there with retaining walls. Lots of good options with the GeoWeb system. Again, you can do vegetation, you can do stone, you can do concrete depending on your needs, and pretty much any extreme weather event. You got seismic, you got hurricanes, avalanches, anything like that can be mitigated with the GeoWeb system. You can help mitigate the impacts on our lives by building up your preventative maintenance solutions. We're building out and living in more areas every day, in areas that maybe we wouldn't have gone to initially because it is a seismically active area. But now we're there. People are living there. Houses are being built, offices are being built there. So let's protect them. Let's make sure that as the weather changes and as extreme events become more common, that we can help prevent damage and potentially even loss of life by building out these areas and making sure that they are in the best shape that they can be. Little bit of housekeeping, I promise this is the end. So we do have a complete solution, and that includes our technical assistance from people like me on our engineering team, where we work with you, contractors, landscape architects, engineers, owners, whoever you are, and we offer a free project evaluation service for any type of GeoWeb application. So the form is on our website, prestogeo.com. Fill it out with as much information as you have. You can attach documents such as geotechnical reports or site photos. It comes directly to us. And then we get you a evaluation that includes CAD documents, supporting calculations, specifications, things that you need to put directly into your bid documents, help you talk to your regulators, make sure everybody is on board and comfortable, and we get you everything that you need. We're going to work with you to get you that best solution for your project, because there is no one right size. It is very project dependent, but that's why we're here. We are going to tell you what those project solutions are. And one last thing, we do deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so that you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine prints. Okay, last bit of housekeeping. If you watched live today, March 11th, you will get a PDH credit for listening to me from GoToWebinar. That will show up in your inbox by the end of the day as an email from GoToWebinar, and that'll tell you how to get your PDH certificate. This webinar has also been recorded and will be put up on our webinar dashboard. You are automatically enrolled in the webinar dashboard, so you can go on there, you can review this webinar, go through our library of previous webinars, and you can earn PDH credits from there as well. So by the end of the week, you will get another email from Presto Geosystems telling you how to access your webinar dashboard if you don't already know. So that's 2 potential emails, one from GoToWebinar by the end of the day, and one from Presto Geosystems by the end of the week. And if you aren't seeing those, or if you do have any questions about getting your PDH certificates, feel free to reach out to us. More than happy to help you with that. Here's my contact info. Please feel free to reach out to me. If you've got a specific project you want to talk about, if you are 10,000 foot, hey, would this even potentially work on my site? Or just tell me more about GeoWeb. I've never heard of it before. Let's talk. I'm more than happy to go over specific details, general details, installation, anything like that. I am here for that and more than happy to discuss. I am going to stay on for just a little bit and try and answer some of the questions that have come in through the Q&A tab. Those are also being recorded, so if you do need to get off, I fully appreciate that. Thank you so much for your time. The Q&A is going to be recorded, so get on the dashboard in a couple of days when this is uploaded, and you can get that Q&A session then. Or if you've got a couple extra minutes, stay on with me. I'm going to go through just a couple of the questions live, and then I'll get to specific questions. I'll email you answers at that point. So let's see here. What type of vehicles can drive on these systems? And so it's a great question. You can do pretty much any type of vehicles. You can have both wheeled and tracked equipment. So if you are having tracked construction equipment, skid steer, excavator, even mobile cranes, something like that are on tracks, those are okay. The tracks aren't going to damage it too much. We just need to make sure that we're aware that that's the type of vehicle that's driving on there. Those are obviously typically construction equipment, so they're more of a temporary thing. Permanent, usually it's more vehicle loads, but you can have up to anything highway rated. So if you're in the US, that's going to be AASHTO H25 loading, but you can go heavier than that too if you do have red flag vehicles that have excessive weight. We can handle those as well. We just need to account for them. And so you don't have to be limited by the vehicles that you use. And in terms of how they move on the GeoWeb system, the GeoWeb is going to be, the panels themselves are going to be slightly covered. So you would fill them up with your info material, sand or stone or what have you, and then overfill a little bit so you don't actually see the plastic material, because you don't want, if you can help it, you don't want direct contact between your vehicle or your track with the GeoWeb, the GeoWeb panels. And so that's what's going to help protect the panels from like your turning loads or the tracks that could potentially really eat that up. Having that little bit of an overfill helps protect the panel itself. And then once you've protected the panel, it's going to help hold all that material in place. That material is not going to get pushed away due to the cars driving or turning or the tracks running across it, anything like that. So it's a really great way to have pretty much any type of vehicle that you need run through those type of systems. So it's, yeah, great question. There is no vehicle limit. There are some practical limits based on how much excavation you want to do. But feel free to reach out to us if you know you've got some funky equipment going across the top of it. We've probably seen it before, and we're more than happy to get you that solution. Let's see. Can you fill it with soil for driving on, or a lightweight fill, or something that you typically wouldn't drive on without it being protected? And so yes, you can use soil, you can use those lightweight fills, you know, there's those lightweight aggregates that are kind of like pumice stone. I don't know, that's not my area, don't quote me on that. But yeah, lightweight aggregate, things like that. You can use that as your infill material. We have some specifications about that that we recommend, that we can get to you if you are curious about that. But yeah, if you want a green road, maybe it's, you know, an access road that you're not going to drive on very much. Maybe it's an overflow parking lot, and you want that to look like a natural lawn, but then still be able to support vehicles on top of it. The GeoWeb is a great way to do that. It's a great solution for that. So yes, definitely. Let's see, with some questions about the slope. What's the maximum slope or maximum height of a slope? So yeah, so the GeoWeb system, if you are doing the slope protection system where it's just the single layer as your superficial erosion, we typically say try and limit it to around 55 degrees or shallower. So that's like a 0.75 horizontal to 1 vertical is where we kind of draw the line. We've done steeper. You can go steeper than that. It just becomes a real question about anchorage and how you're holding it all in place. But for most practical applications, a 1-to-1 slope is more than enough for most people. But yeah, so if you have a really steep slope, that's fine. If you're going steeper than that, we might recommend switching to a retaining wall, because that can get you to near vertical. So that might be a question that we can talk about on a project specific basis on, what does your site look like? What are your excavation needs or anticipation, that sort of thing? Can you build up a wall, that sort of thing? And just remember with that, if you're just doing the single layer of the slope protection, that the slope itself needs to be stable. And so that's more the limiting factor than the GeoWeb system in that case. The GeoWeb system can be placed on very, very steep slopes, but if the slope itself isn't stable at 55 degrees, then the GeoWeb system isn't going to help. It's, you're going to have that concern anyway. So that's kind of why that 45 degrees is probably most practical, because that is something that you do see out in real life, are naturally occurring 45-degree slopes. So you can put a protection system on the top of that. And in terms of height, how high these slopes can get, there is no real limit. We've done very, very tall slopes, hundreds of feet high, that have, slope faces that are hundreds of feet long. That's starting to become more of an installation question than a can it work question, than a solution based. So then we sort of transition to, okay, how do you install something like this? That's obviously a massive project if it's 100 feet tall. So how do we install it? We've done it. We have the solutions. More than happy to talk about them with you. So don't let extreme projects, whether it's very steep, whether it's very tall, whether it's in a hard to reach area, don't let extreme conditions stop you from trying to see if this is the solution that could work. That is the benefit and the real need of the GeoWeb system, is that it does fit those extreme conditions, extreme site conditions, extreme weather conditions, anything like that, that typical solutions that you might already be thinking of, those don't work for some reason. That's why you would do the GeoWeb system. Hope that makes sense. Let's see, some questions about walls. I'm going to make this the last one because I've gone so far over. So how do you anchor some of those walls? So I mentioned there was that project that I mentioned in Hawaii that had the landslides. They did GeoGrid tiebacks. So that's something that if you are a wall builder, if you've done gabion basket walls or MSC or masonry block walls, anything like that, GeoGrid tiebacks are going to be familiar. You're going to understand, like, that's the exact same concept if you use the GeoWeb wall with a GeoGrid tieback. You can also do soil or rock anchors, depending on what you're looking at. So basically you would tie with tendons a soil nail or a rock anchor to the GeoWeb panels that are still there, building up basically just the fascia then. So it's just building the face of the wall that's going to be probably vegetated just to make it look nice, and anchor that into your soil or your rock slope or wall face that's there. That would hold it in place. You can do a mix of gravity structure and reinforcement. We've done that where they do a little bit of area with big excavation and they reinforce it with some sort of geosynthetic, and then they do a gravity structure on top of that because there isn't as much room for excavation. So there's a lot of flexibility there. But I mentioned designing retaining walls is a beast, and I barely even scratched the surface of it today. So I really urge you to either attend the webinar that we have coming up about it, or get on the dashboard. And I think we have one in our library. We have a lot of resources online as well for how that sort of thing can work. But there's a number of different reinforcement options depending on what your global stability concerns are, what your site looks like. Do you have room for excavation, or are you up against a rock face? Is it a cut slope or a fill slope? Do you have seismic concerns? Is there water flow? There's a lot of different pieces for how to build up a retaining wall. I'm sure I'm preaching to the choir on anybody that is a wall designer. So yeah, but there is some flexibility, and then you can do topsoil and allow it to vegetate so you get that nice green wall. You can put in stone, concrete. You can shotcrete the face if you want to just cover the whole thing in shotcrete. We've seen that. So a lot of, whatever face you need, you can get as well. It's not limited to one or the other. So thank you everybody who has stayed on with me. I appreciate the extra little bit of your day. I hope you guys all have a wonderful the rest of your day. And we see you at future webinars, and that I hear from you if you are ever curious about the GeoWeb system or any of our other products. And again, please feel free to reach out if I didn't answer your question today, or if you think of another one as you move forward. I'm always happy to discuss anything that you might be curious about. So thank you, everybody. I hope you all have a wonderful rest of your day, and I will see you at future webinars. Bye.